Come over here. Hey, you remember me, I'm Theo. You're Mark, right? I'm about to show you something that they don't show you in school. It's something really good. Graphing cosine and sine. This is some good stuff right here. We got the equation y equals a sine or cosine bx plus c plus d. We're going to start with here the amplitude. The amplitude of the graph is the maximum height of the graph when it from the x-axis. You find it by finding the absolute value of a. Next, we move on to the period. The period is the distance along the x-axis that is required for the function to make one full rotation. The equation for that, 2 pi over b.
Oh wait, I know this. The phase shift. The phase shift is the measure of how far the graph has shifted horizontally. The equation will be negative c over b. And the vertical shift is the measure of how far the graph has shifted vertically, either up or down from its initial position, which is just d from the equation.
Hi, I'm Chelsea. Now I'm going to be performing the y equals negative 3 sine x graph. Okay, so we have the amplitude, which we're going to start with, and here it's negative, absolute value of negative 3, which equals to 3. Our period is 2 pi over b, b being 1, since there is no b, it's 1, and that's 2 pi. And then we get 2 pi over 4, 4. And you simplify it to pi over 2. So we have that down. Now we're going to do our x's and y's. And we're going to start with 0. And then add from there our period over 4, which is pi over 2. Pi. 3 pi over 2. 2 pi. We should always end with our period, and of course here our period is 2 pi, and we're ending with 2 pi. And now from here we just plug in the x's into our problem. Negative 3 sine 0 is going to be equals 0. Plug in pi over 2 into x, which gives you 3, and so on. And 0. So we're just gonna plot this into the graph here. But before we do that, we of course want to do our parent function. Now we're gonna plug in the x's on the axis. 2 pi, 3 pi over 2, and 2 pi. But before we graph the actual 3 sine x, negative 3 sine, we're going to do the parent function starting from 0, making its way to pi, and dipping down into 2 pi. That's the parent function. And now we're going to graph this. So 0, 0, pi over 2, 3, pi 0, 3 pi over 2 is negative 3, and 2 pi is 0. So I'm just gonna and that is our graph.
My name is Yuval Segura from the AV gang, and I'm going to show you guys how to do a cosine graph problem. So here we have our problem. Y is equal to the cosine of 2x. And the first thing to remember when performing a problem like this is our formula. Our formula is going to be a cosine bx plus or minus c, and this pretty much helps us when we're throughout the entire problem, and I'll be talking about this formula through the duration of the video. So the first thing to do when performing one of these problems is finding the amplitude. Now our amplitude here is going to be the formula for the amplitude is the absolute value of A. Now A in this case would be 1 because we know if there's nothing in the front, it's always 1. So the absolute value of 1 is equal to 1. So this is our amplitude. Now the next thing we want to look for is the period. The formula for the period is going to be 2 pi over B. And B in this case would be 2. So 2 pi over 2 is going to be just pi. And then you also should find the period over 4. Period over 4 right here. And this would be equal to pi over 4. Alright, now that we have all of the characteristics written out, it's time to actually solve the problem. So first I'm going to draw the graph. So the graph should look as follows. 1 up here, -1 down here, and then 4 spaces here are 4 x coordinates. And then we're going to do our x and y charts. X and y. Now the xy chart should look as follows. Over here 0 for the x to start with, which the y point would be 1 for. Pi over 4, to which the y point will be 0. Pi over 2, to which the y point should be -1. 3 pi over 4, to which the y point will be 0, and finally it'll conclude back at the period of pi, which the y point will be 1. Perfect. Now we will label this. Alright, and now finally, all we need to do now is draw the graph, and I will draw the graph right now with this here. Start with up here for the 0, 1. Here for when y is 0. Go all the way down to here as y is -1. Come back up to 0 over here. And then back to the original 1, just as before, over here. And now I will connect the dots. And the graph is completed.
Hey, we all know that sound travels in waves and frequencies. But did you know that a French scientist and mathematician by the name of Jean-Baptiste proved that any waveform that repeats itself after a period of time, such as a musical sound, can be expressed as the sum of an infinite set of sine curves? In other words, forget all of that. The velocity that is initial in the x direction equals the velocity of cosine, and the velocity initial in the y direction equals the velocity of sine. With these components, we can find the displacement or the distance, the object.
Thank you for catching the Marlins on Graphing Sin and Cosine.
Bye.
Catch us next time!